This video will cover the topic of mass spectrometry. Mass spectrometry provides information about the molecular weight of a species. It separates species based on their mass and their charge. Mass spectrometry works by using a high-energy source to ionize a molecule. A high-energy source is most often an electron beam, and ionization gives that molecule a charge by knocking off an electron. So our high-energy electron beam is combined with the molecule, which I'll represent by a large M, to give us the molecular ion, which is the same as the molecule except that it's missing an electron, so it now has a positive charge and a radical, a single electron, and two electrons, one we started with and one was the one that was knocked off the molecule. Our molecular ion, our molecule that's missing an electron and now has a positive charge, is what we analyze using mass spectrometry. The molecular ion, once created, is sent down a curved flight tube to a detector. So the inside of a mass spectrometer looks something like this. The sample is injected into the ionization chamber. It's within the ionization chamber that the sample is hit with this high electron, high energy beam to knock off an electron and to give that sample a positive charge. The molecular ion that's formed is then sent down the curved flight tube to a detector at the end. The curved part of the flight tube is surrounded by a strong magnet. The molecular ions, are attracted by the magnet, and we can change the strength of the magnet to allow ions of certain masses to bend through the flight tube. So the molecular ion is created in the ionization chamber, and it continues to fly straight unless it's bent by the magnet. We can control the magnet to allow only certain masses to bend at the correct angle to continue on to the detector. We can then slowly scan through all strengths of the magnet to allow each mass to hit the detector, and then we know what the mass is of each of the ions that is hitting that detector, and that produces something called a mass spectrum. A mass spectrum is a graph that plots the abundance of the ion on the y-axis versus the mass-to-charge ratio on the x-axis, otherwise known as m/z. For most small organic compounds, the molecule can't hold more than a +1 charge, so the mass-to-charge ratio is equivalent to the molecular weight. To determine a compound's molecular weight, we need to look for what's called the molecular ion peak, the peak in the mass spectrum that's due to the molecular ion. The molecular ion is the ion corresponding to the mass of the original molecule. Remember, it's lost an electron, and since the mass of an electron is negligible, it essentially is equal to the mass of the original compound. And we're looking for the molecular ion peak in the mass spectrum. This is the m/z, or mass-to-charge peak, that corresponds to the molecular ion. This is usually the peak with the highest mass, not the peak of highest intensity. The other peaks at smaller mass-to-charge ratios are due to other fragments, and we're not going to worry about these. Let's look at some example spectra. This is the mass spectrum for acetone, whose structure is shown here. You'll see that the molecular ion peak, which is labeled, is the peak at the highest mass-to-charge ratio and corresponds to the molecular ion. It isn't the most intense peak, which is here. Intensity has nothing to do with the molecular ion, it just has to do with how well a particular ion flies in the mass spectrum. So what we're looking for is the molecular ion peak to tell us the molecular weight of the species, which in this case is 58 grams per mole. This is the mass spectrum for pyridine. Again, structure is shown here. The molecular ion peak is labeled because it's not the peak of the highest mass-to-charge ratio. If I give you a spectrum where the molecular ion peak is not the peak at the highest mass-to-charge ratio, I'll label it with the molecular ion symbol like I've shown here. Again, the molecular ion peak corresponds to the molecular weight of the species, which we can see is at 79. So as you can see, mass spectrometry gives us information about the molecular weight of a species. And if you'll remember back to earlier in the semester, when we talked about determining molecular formulas, this information, the molecular weight, in addition to the empirical formula, can be used to calculate the molecular formula of an unknown compound.